Students, in this video I will demonstrate the second experiment under part A. So this experiment is using a 741 op-amp, design an 1 kHz relaxation oscillator with 50% duty cycle and simulate the same. So for this the components required are, so we need one op-amp, that is IC number 741. 741 is an IC number for the op-amp. Then we need 3 resistors. The value of the first 2 resistor is 10 kilo ohm and the third resistor is 5 kilo ohm. So as per the calculation which I have explained in the previous video, so the feedback resistor, the value of the feedback resistor should be 4.7 kilo ohm. So we will be using 4.7 kilo ohm as a feedback resistor. And also we need one capacitor. So the value of that capacitor is 0.1 microfarad, and we need DC regulated DC power supply, and also we need a CRO to get the output. Now I will demonstrate this experiment. So as usual, to make the connection I will be taking a breadboard. So this is a 741 op-amp. So you can see here there are 8 pins in total, 4 pins on each side, and there is a notch at the top. So I will fix this op-amp onto the breadboard. Okay, so this is the breadboard actually. So there are 4 columns. So I need to fix this op-amp between the column 2 and 3 onto the middle of the breadboard. So on the left part the pin number starts from 1, 2, 3, 4. On from the bottom right corner pin number starts from 5, 6, 7 and 8, and there is a notch at the top. So according to the circuit, see here, I will be using a series resistor R1 and R2, where the value of R1 and R2 is 10 kilo ohm. So what I will do is I will take up one 10 kilo ohm resistor and I will connect that. One end of that resistor is connected to the 6th pin, another end is connected to the 3rd pin, and another 10 kilo ohm resistor. So I will take another 10 kilo ohm resistor. One end of that resistor is connected to the 3rd pin, another end is connected to the ground. See here, this is the 10 kilo ohm resistor. So one end of this resistor is connected to the 6th pin. So the 6th pin is from the bottom right corner, pin number starts from 5, then 6. So I will connect one end of this resistor to the 6th pin, another end is connected to the 3rd pin. So this is the 3rd pin. So another end is connected to the 3rd pin, like this. Okay. So next I will take up another 10 kilo ohm resistor, where one end of this resistor is connected to the 3rd pin, another end is connected to the ground. See here, this is the ground connection. So the column A, I will make this as a ground connection. So in column A there are 2 columns. So here the connection should be in parallel. Okay, which means that one below the other. We need to consider the pin one below the other on the column 1 of the breadboard. Okay, next I have connected the 2 resistors, series resistors, like this, where for the first 10 kilo ohm resistor, one end is connected to the 6th pin, another end is connected to the 3rd pin. The second 10 kilo ohm resistor, one end of that is connected to the 3rd pin, another end is connected to the ground. So I will be considering the column A, that is the first column, as a ground connection. Next we have a feedback resistor. The value of that feedback resistor is 4.7 kilo ohm, where one end of that feedback resistor should be connected to the 6th pin, another end is connected to the 2nd pin of op-amp 741. See here, this is the 4.7 kilo ohm resistor, where one end is connected to the 2nd pin, another end is connected to the 6th pin of an op-amp. See here, this is how we need to make the connection. One end of this 4.7 kilo ohm resistor is connected to the 2nd pin, another end is connected to the 6th pin. From the bottom right corner, pin number starts from 5 and then 6. So now I have connected 3 resistors. Then we need one capacitor. The value of that capacitor is 0.1 microfarad. Here the capacitor should be connected between the pins, that is the second pin and another end should be connected to the ground. So as usual, I am taking one capacitor. The value of this capacitor is 0.1 microfarad. So there is no polarity in this. Okay, so one end is connected to the second pin, another end is connected to the ground. So this is the breadboard, where one end is connected to the second pin, another end is connected to the ground. So this is how we need to make the connection, where one end is connected to the second pin, another end is connected to the ground. Okay, so the next thing is we need to give a power supply to the op-amp 741. So this is the DC power supply. So here we will be having a plus 12 volts and minus 12 volts, and also we will be having a ground connection. Okay, so here the plus 12 volts should be connected to the 7th pin and minus 12 volts should be connected to 4th pin. See here on the circuit, so here the power supply should be given like this. The plus volt should be given connected to the 7th pin of IC-741, and the minus 12 volts should be connected to the 4th pin. Now I will take up one wire. So one end of that wire is connected to the plus 12 volts. So another end is connected to the 7th pin. So from the bottom right corner, pin number starts from 5, 6 and then 7. So I will connect the other end of this wire to the 7th pin. Next, I will connect one wire to the minus 12 volts DC power supply. Another end is connected to the 4th pin. So the IC on the left hand side, the pin number starts from 1, 2, 3 and 4. See here. So another end of this wire is connected to the 4th pin. Then we have a ground connection or a COM connection. So that should be connected to the parallel. So that should be connected to the first column, which we have considered as the ground connection. Because if I want to convert this series or a parallel connection as a ground connection, then obviously I need to give an ground connection to this circuit or to this column. So what I will do is I will take one wire. One end of this wire is connected to the ground or COM of DC power supply. Another end is connected to the first column. So now this entire column has become a ground connection. So after this, moving on to the CRO. So as you all know, so there are two channels on the CRO. So channel 1 and channel 2. So on the channel 1 we will be having two ends. One is a positive, another one is negative. So this is the channel 1 probe, this is the channel 1 probe. So the red colored one is usually called as the positive, and the black color one is called as the negative. So I will take one wire. I will tie up the wire onto the positive pin of the channel 1, and another end should be connected to the 6th pin. So usually the output will be obtained from the 6th pin of op-amp. So what I am doing is the positive wire of the channel 1 is connected to the 6th pin of 741. So I am connecting the other end of this wire to the 6th pin like this. Next, I will take up the channel 2. So again in channel 2 we have a red color or the positive pin. So what I will do is I will take up one wire and I will tie up this to the positive of channel 2. And as I need to get an capacitor waveform, the other end of channel 2. So the other end of this wire should be connected to the capacitor. Capacitor is connected to the second pin. So what I will be doing is I will connect the other end of this wire to the capacitor or to the second pin of 741 op amp. See here, as we have two channels on the CRO, the channel 1 positive is connected to the 6th pin of 741 op amp, and channel 2 positive is connected to the second pin of 741 op amp. So usually from the channel 1 we will get the output of an op amp, and from the channel 2 we will get the output of the capacitor. So we should get the capacitor waveform. So that's why the positive end is connected to the capacitor, that is to the second pin, and the negative terminal of both the channels, channel 1 and channel 2, should be grounded. So what I will do is I will take up one wire and I need to make this as a ground connection. So I will tie up the one end of the wire to the channel 1 and channel 2 negative. After that, the another end is connected to the ground connection in the breadboard. So this is the ground connection which we have considered on the breadboard. So I will connect this end to the ground connection. So this is how I need to make a ground connection. So now we are done with constructing the circuit. We need to verify the output on the CRO. So before verifying, first we need to switch on the DC power supply. Next we need to switch on the CRO. Yeah. So this is the output of a relaxation oscillator. So here you can see we have an T on as well as a T off. The length of both the T on and T off are equal because we have constructed this circuit for 50% duty cycle. 50% duty cycle means both the T on and T off, the length of both the T on and T off should be equal. So this is approximately equal, so not exactly equal. Here the T on and T off are approximately equal. So this is the output of channel 1. So that is nothing but the output of 741 op amp. Next, output of the capacitor is see. So this is the output of an 74 ohm op amp. So the positive, the channel 1 positive is connected to the 6th pin to get this output. Next, channel 2 positive is connected to the capacitor. So to see the capacitor waveform, so this is the sawtooth capacitor waveform, where positive pin of the channel 2, the positive terminal of the channel 2 is connected to the capacitor, that is to the second pin. So this is what the capacitor waveform, that is in sawtooth waveform, that is in sawtooth. And if you want to get both the waveform, so here you should turn this switch to the dual mode. Okay, when you turn this switch to the dual mode, you will get the channel 1 waveform as well as you will get the channel 2 waveform. Channel 1 is the output of an 74 op amp, channel 2 is the output of a capacitor. So these are the two waveforms which you need to get from this experiment. So if this circuit, now we will construct this circuit on the simulation software. So the components which is required to construct this circuit is 5-terminal op amp. So this is the 5-terminal op amp. So as we have discussed, there are two inputs to this op amp. One is inverting and another one is the non-inverting terminal. Another one is another should be connected to plus VCC, and the fourth pin should be connected to minus VCC. So the inverting input, the pin number for the inverting input is a 2, and the pin number for non-inverting input is a
3, and the pin number for plus VCC is 7, and the pin number for minus VCC is 4. Okay, so here we will be using VCC. The value of VCC is 12 volts, and output can be obtained from the op-amp, and the pin number is 6. And we have one capacitor. Here we will be using one capacitor, and the value of this capacitor is 0.1 microfarad. And we have a feedback resistor RF. As per the calculation, the feedback resistor is 5 kilo ohm. Then we have two series resistors, R1 and R2. So we will be using 10 kilo ohm for R1 and R2. Both should be equal, because in relaxation oscillator, we need to get a square waveform. If we want to get a square waveform, both the resistor, that is R1 and R2, should be equal. So that's why I am using R1 and R2 as 10 kilo ohm. Now we will do this circuit connection on the simulation software. So go to search bar, just type electronic workbench. Double click on this electronic workbench. Okay, so this is the application. Now we will drag and drop all the components which we need for this experiment. Here we need op-amp IC. So go to analog and click on the second component. So just drag and drop this second component. So this is an 741 op-amp which has 5 terminals. So one is inverting input, another one is non-inverting input, another one is connected to plus VCC, another one is connected to minus VCC, and the output is obtained from the 6th pin. That's the another terminal. So there are 5 terminals on this 741 op-amp. Next, we need 3 resistors here. So I will drag and drop a 3 resistor. One is a feedback resistor. Value of that is a 5 kilo ohm, or a standard value is a 4.7 kilo ohm. You can use anything for the to construct the circuit on the simulation. And there is a 2 series resistor. Both are equal to 10 kilo ohm. Next, also we need one capacitor, right? So I will drag and drop one capacitor. Next, what else we need? We need 2 VCCs. One is for plus 12 volts. Another one is for minus 12 volts. I will rotate this second VCC. Okay. Next, we need grounds. A single circuit can have multiple grounds. So I will be taking one ground for plus VCC, and I will be considering another. I will drag and drop another ground for minus 12 VCC. Then what else we need? We need a CRO, right? So go to instruments, click on this third component, just drag and drop that CRO. So as we have discussed the CRO, so there are 2 channels on the CRO. The lower part, there are 2 pins on the lower part. The first pin is a channel 1 positive. The second pin on the lower part is a channel 2 positive. And again, there are 2 pins on the right hand side of the CRO. So both are channel 1 and channel 2 negative. Both the pins are considered as a channel 1 and a channel 2 negative. Both should be connected to ground. So I will drag and drop one ground for this CRO. So these are the various components which we need to construct this circuit. Now we will construct this circuit. So according to the circuit, so there is a feedback resistor, which is one end of this feedback resistor is connected to the second pin. One end of this feedback resistor is connected to the second pin. Another end is connected to 6th pin. Now we will do this connection. One end is connected to the second pin, that is nothing but the inverting terminal of an op-amp. Another end is connected to the 6th pin. So this is how we need to connect this resistor, and the value of this resistor should be 5 kilo ohm, right? So just click on that resistor, right click, then select component properties. Here you need to type 5 kilo ohm. Okay, just click on OK. Next, we have two series resistors. So the value of these two resistors should be 10 kilo ohm. Select this resistor, right click, go to component properties, and here you need to type 10 kilo ohm. Click on OK. Next, select the other resistor which we need for this, for designing this circuit. Select this, right click, go to component properties, and type 10 kilo ohm, and just click on OK. Then we will do this series connection where one end should be connected to the sixth pin of an op amp, that is nothing but the output of the op amp. Another end should be connected to the non-inverting terminal of an op amp. And coming to the another resistor, the second series resistor, one end is connected to the non-inverting terminal, another end is connected to the ground connection. So I need one ground for this. So this is how we need to make this connection. Okay, so next we have one capacitor where one end of the capacitor is connected to the inverting terminal of an op amp, another end is connected to ground. We will do this connection now, where one end is connected to the inverting terminal. So this is the wire which is connected to the inverting terminal, and I will take one ground. Another end of the capacitor is connected to ground, and value of the capacitor should be 0.1 microfarad. So select the capacitor, right click on that, go to component properties, and type 0.1 microfarad. Click on OK. Then we need to do the plus 12. We need to give plus 12 volts for the op amp, where positive end of the plus 12 volts is connected to the seventh pin, right? So the positive end is connected to the seventh pin, and negative end of that VCC should be grounded. Negative end should be grounded like this. Then moving on to the minus 12 volts. So the negative end of the VCC should be connected to the fourth pin of op amp. As per the circuit, see here, the negative end, this is minus VCC. So the negative end of the VCC should be connected to fourth pin, and positive end of this VCC should be connected to ground. We will do this connection. Yeah, negative end is connected to minus 12 volts, and the positive end should be grounded. Yep. So we are done with this. Then we have a CRO. We need to make a CRO connection. So on the right hand side, you will be having 2 points. Both belongs to the channel 1 negative and channel 1 and channel 2 negative. So coming to the lower part of the CRO, there are 2 pins. So the first one is a channel 1 positive, where this should be connected to the output of the op amp, that is 6th pin. Okay, so then we need capacitor waveform, right? So the channel 2 positive is connected to the capacitor. Channel 2 positive is connected to the capacitor like this. So this is how we need to do the circuit connection. So there are 2 channels on the CRO. One is channel 1, another one is channel 2. Channel 1 positive is connected to the 6th pin of op amp, which is an output. Another channel, that is channel 2, the positive terminal of the channel 2 should be connected to the capacitor to get the capacitor waveform. Now we will see the output. So just double click on this CRO. So when you double click on this CRO, switch on, vary the time. Yeah. So 1 millisecond, right? So we are constructing the circuit for 1 millisecond. Then switch off the CRO like this. So here you have a button, switch on and switch off. This button is considered for the CRO to switch on and switch off. Yeah, so this is the waveform. Just increase the time or decrease the time so that you can clearly see the waveform. Yes, so this is the waveform. One is the first one is the square waveform. In the square waveform, T on and T off, the length of a T on and a T off both are same. And the second waveform is the capacitor waveform, that will be a sawtooth waveform. The capacitor waveform will be in a sawtooth, and the output of the op-amp, the output waveform of the op-amp 741 will be a square waveform. So this